Hello, beautiful learners. Today we'll be looking at nonlinear data structures. And under this, we will be understanding what graphs are and trees in computing. So let's look at what graphs are. A graph is a collection of nodes, where the nodes are also called vertices, connected by edges. What this means is that you have a node where here I'm representing them with circles, and then we have lines connecting them, and you can see that the lines go all around, going back, connecting the very first one, the green to the blue. Now, there are different types of graphs, and we have directed and undirected graphs. So with a directed graph, it simply means that you have the edges from one node, all showing a direction towards another node in that order. So there is a direction. So for instance, here we can see that the edge is from the green to the purple to orange to blue, and then from green to blue, and then from the purple to blue. You can see the direction in which it is flowing. So these are called directed graph. On the right side, you can see that the edges have double arrows both at the ends. Do you get it? So it simply means that here, these arrows here are showing by directions. So it means one node can move its items to the other node, and the other nodes can also bring back the items to the other node. Do you get it? So there is a by relationship between them. Again, we can also decide not to represent these edges with any arrow. So we can refer to that one as what? Undirected. Let's now look at some applications of graph. So graphs can be applied in maps like road maps, where you have the towns being indicated with the red icons here. So in my map, you can see Ejiso, you can see Ho, and you can see Dambai as what my nodes. And the blue line here is representing the edges. This is showing the road, how they are connected all around. So these become a graph, and this is an application of a graph. Again, in social network, you can see how Twitter, LinkedIn, Instagram, and Facebook are interconnecting all these users. You have some users using multiple of these social platforms. And this is also showing how graphs are interconnected with users on social platforms. Let's now look at what trees are. In computing, a tree is a type of graph, but it doesn't have any loop. So it simply means that you cannot get back to the start by following the connections. But unlike the graph, you can see how we can follow the edges back and get back to where the very starting point. So in trees, see it as a family where we have the grandparent, and then we come to the parent, and then we come to the children, and then the children can also have children. Now, we represent the grandparents as the roots, meaning they are the roots of the generation. And then they give birth, and then those become children. So here, my blue circle here is representing the roots, and then you can see that on the right I have parents. I'm calling this parent because you can see that this parent is having two children. That is how come I'm calling this person a parent. And the left side of the root, I'm referring to this as a leaf because you can see that this particular one doesn't have any child, so it becomes a leaf. Again, I'm calling this a leaf because this particular node doesn't have any child. Now, under the parent, you can see that there are two children. One of the children is having a child, and that child now becomes a leaf. On the extreme right, it's another child. Under a parent, we can refer to this child also as a leaf. I hope this concept is clear. Let's now look at the types of trees. We have the binary tree. It simply means that every node is having two children. That is what it means. So you can see that the root here has given birth to two. And then the children under it are also having two children. Basically, this is what a binary tree means. Okay. Let's look at another type. We have the binary search tree. This is a little complicated, but pay close attention and you will get the understanding. Now, the binary search tree, imagine it this way, that you want to build a binary search tree with the following numbers. So again, we are looking at it in terms of binary. It means that every node is supposed to have two children. So we are starting with the number 15. It means that the root is 15. So 15 becomes my root. Now, it have this rule that any number which is less than the root or the parent goes on the left, and any number which is greater than the parent or the root goes on the right. So my first number here is 15, so that becomes my root. 10 is the next number. Is 10 greater than 15? No. So I'm putting 10 on the left. 20 is the second number after 10. Is 20 greater than 15? Yes. So I can put 20 on my right. Then the next number is 8. Now, we have exhausted the root having two children based on 10 and 20. So the next number is 8. And the question now is 8 greater than 10? No. Is 8 greater than 20? No. But then 8 is less than two of these numbers. The best place to put it is to put it under the 10. Because the other numbers which are there are all greater than 10. So I'm going to put the 8 under the 10, but at the left side, because all the numbers that are lesser than the parent or the root goes to the left. Is 12 greater than 10? Yes. So I can put 12 under 10, but this time it is at the right side because it is greater than 10. Then we have 17. Is 17 greater than 20? No, 17 is less. So I can put it at the left side of 20 and put 25 at the right side of 20. So I've just explained how this works. So you can decide to play around it, try some numbers, and look at how the binary search tree works. Okay. Let's now look at some application of trees. So trees can be applied in file system. Like for instance, I am a student who has gone to SHS. So I've created a folder on my computer as school notes. and I've under the school note, I have folders in that folder where I have Form 1 and Form 2. I'm not yet in Form 2. So in Form 1, I have some files which I'm creating notes in computing, notes in ICT, and notes in maybe biology, all forming up into my Form 1 folder. So you can see how we've applied trees in creating files and folders. So this is a typical use case of trees. Again, we can use trees in database indexing. You will learn these as you get better in computing.